It's hard to tell, right? It's hard to tell. Maybe we need more points, right? Maybe we need more points. So let me do more points. Let's do 800 points and see if my computer stops working for me. I'm going to do 800 points.
It's like that infinity thing with the cup you were telling us about. We're adding such small numbers, it's insignificant because the decimal places keep getting bigger.
Yeah, these are getting smaller, right? We know that these are all getting smaller, right? We know these are getting smaller because this goes to 0. So each time we add, we're adding less and less and less. But look, I went out 800 and we're still growing, aren't we? Now we're only up at, I'm having the computer do our sum for us. And do you see I'm only at 7.1 something? But at 100 points, I was back here, right here, I was back like at 5 point something. And now I'm at 800 points almost, and I'm at 7. So does that look asymptotic? Does it look like I'm bounded above or not? Doesn't look like I am. I'll try 1,200 points. I don't know what my computer's going to do. That got real slow when I did it. Oh, okay, it made it. It didn't grow much, did it? But it's still growing, yes? It turns out, I can't prove it to you, not yet. It does turn out that this diverges. It goes to infinity. I'll show it to you in a little while, all right? Maybe today. So, do y'all understand I'm using the computer to show you the two different ideas here? You've got the sequence, it goes to 0. The series looks like it's going to infinity here. Questions? Yes?
Can you always say that if the new sequence diverges, the series diverges?
Say again?
Can you always say that if the new sequence diverges, the series diverges?
Yeah, this new sequence, if this diverges, that means the series diverges. This dictates what we say about the series. So if this new sequence converges, we say the series converges. If this new sequence diverges, we say the series diverges. I thought you were asking me a different question. I thought you were asking me, if this diverges, then what do you think you can say about the series? Do you think it converges? If this diverges, then that converges? Guaranteed every time? Okay, that's what I thought you were asking. Let's leave that as an open question. That's what I thought you were asking. All right, let's look at one more example. We've done the two that I've shown you, right, are n, and we all agreed that what does this sequence do? What does the sequence do? This one, n. A sub n is n. That's 1, 2, 3. So what does the sequence do? It diverges, right? Let n go to infinity, that goes to infinity, right? What does the series of that sequence do? That's not here. It was the one where we did 1, 3. It diverged as well, didn't it? So I've given you that example. I gave you this example where the sequence converged, but the series looked like it diverged, right? I'm going to give you one more. 1 over n cubed. 1 over n cubed. Does that sequence converge or diverge? What is it? Converge to 0. Why? How are you doing that? Take the limit of this, right? Take the limit of this. It's important you're understanding the language, the way I'm speaking to you, the words that are coming out of my mouth, right, are important. What is this sequence doing? It's converging, right? What am I doing? I'm taking the limit of this as n goes to infinity, that goes to 0. Okay, let's list them out. 1, and then if you plug in 2, that's 1/8, right? If you plug in 3, that's 1/27th, and then you keep going, right? Now I can start doing the series. I can do these partial sums, and I can see if I start adding those up, if I'm going to converge or blow up, right? Like, is it going to converge to a number, or is it going to diverge? What does your instinct tell you? You think what? Diverge. You think diverge, just like the one before it? Okay, so we'll have to look. 1 over n cubed. So the first one is just 1, right? 1 over n cubed. I add up 1 and 1/8. Then this one, I add up 1 and 1/8 and 1/27, right? And then I keep doing this, right? So the new sequence I get is 1, what's 1 plus an eighth? 9/8? 9/8. And then here we'd have to get a common denominator, wouldn't we? And then we keep doing that. I don't feel like doing it. I'm going to have the computer do it for me, okay? I want you to pay attention. Right now what you're looking at is the 1 over n, right? The 1 over n. Look at what happens when I do 1 over n cubed. Pay most attention to the blue, because we already know when I put 1 over n cubed here, y'all agree the sequence is going to do exactly the same thing? It's going to drop down? Okay, but look at what happens to the blue. Move that up a little bit. Look at that. That looks flatter than the other one, right? It doesn't have that kind of increase to it like the one before had. Let me do some points in here. Let me do more points. Keep an eye on this number down here, 1.20201. I've got 100 points there. Let me just go right to 800 points. It didn't change much, did it? Didn't change much. Let me give you more decimal points. Wait, where are my decimal points? Oh, why don't I have my decimal points here? That's all right. What do you think? A little bit of a different picture, isn't it, than the one before? Doesn't that look like convergence to you? Yes? Because it doesn't have that little slope to it, right? So it does turn out that this one, this new sequence, right, which is the series, does converge. I am not proving it yet. I'm just trying to visually prove it to you. All right?
So if that sequence converges, then the series.
That means the series converges. Yep. So that, now you're taking this on faith, but what I'm saying to you is this, that if you were to take this 1 over n cubed and add these up forever, if you did, it's going to go to some s, and that is going to be a number. All right? It's not going to be infinite. It's going to add up to something. It's going to converge to some number, all right, for this particular series. Yes?
So if it was over the power of 2, would it still converge?
You mean like 1 over n squared?
Yes.
Yes, it will.
So
Yeah.
if it was n minus anything, it would diverge, but because it's 2 power?
Well, I'll just give you the spoiler alert right here now, okay? Like, here's the spoiler. If you have n raised to any power, okay, then this is going to converge if p is greater than 1, and it's going to diverge if p is less than or equal to 1. And it's called a p-series, exactly. We're going to talk more about this later, but that's what we refer to as a p-series. The main thing I want you to take away from this right now is this. I've given you 3 examples, all right? Right now, I've given you 3 examples of 3 different sequences, right? I'm going to put them on the board again. I've given you this one first. A sub n was n, right? And then the next one I gave you was a sub n was 1 over n. And then this one, a sub n was 1 over n cubed, right? Those are the 3 sequences I gave you. In terms of sequences, this sequence diverges, this sequence converges, this sequence converges, right? That's in terms of sequences. In terms of series, right? In terms of the series, sum n equals 1 to infinity of n, if I were to add all those up forever, this will diverge. It goes to infinity when we add them all up. This one, when we add these all up, I tried to visually convince you what? That this would do what? Diverge, right? Now, I haven't formally convinced you of that. I've just visually convinced you that that one diverges as well. And this one, I tried to show you visually, did what? Converged. This goes to some number. This one converged. All right, to some number. Do y'all see this all together here? Now, the absolute most important thing for you to see in this is what most students make a mistake on. If I take this and I ask you, what does that sequence do? We would all agree it diverged, right? And that's because that n goes to infinity, right? So this is a sequence diverged, right? What does this sequence go to?
0.
Converges to 0, right? What does this sequence do? Converges to 0. Look at these two things right here. Both sequences go to 0, right? But their series don't do the same thing. Just because a sequence goes to 0, that doesn't mean that you can determine anything about the series. That's what makes this hard, is that the sequence does not reveal anything about the series. Well, if the sequence goes to 0, you know nothing about the series. It's going to be one or the other, but you can't tell just by that alone. Now, if this happens, then you can tell me for sure this is going to happen. If you have divergence here, you're going to have divergence here. All right? All right, we're still just kind of trying to wrap our heads around this. Let me back this up so my computer will continue to cooperate with me. So this is basically what I'm telling you right now. The big challenge is that some things converge, some of them converge, some can't. We cannot tell by just looking at the sequence, okay? We cannot tell by just looking at the sequence, right? This is the hard part, right? And we will have to develop a set of techniques. We're going to have to develop some methods for investigating when this converges or diverges. We're going to have to be able to figure it out. And this is going to be called our series tests. And there's a bunch of tests. It's kind of like the integration techniques. We had all these different techniques. When it comes to series, there's a bunch of tests. And so I'll give you a series. I'll say, hey, does this converge or diverge? And you'll be like, what test do I use? And you have to figure out what test. All right? So some more notation and language. So we already have seen this notation, right? That's sum n equals 1 to infinity of a sub n is just add them all up, right? Forever. The nth partial sum I just showed you, right? Is where you just add up the numbers, right? The first s sub 1 is just add the first one of the sequence. S sub 2 is add the first 2. S sub 3 add the first 3. S sub 4 add the first 4. S sub n add the first n together. Right? So if I had kept doing this, right? If I had kept doing this, the nth partial sum would be me adding the first n of those up, right? The first n of the numbers in the sequence. Yeah? And then we ask, does it converge or not? And so ultimately, the capital S we're trying to find, right? Whatever, if this adds up to a number, the capital S we're trying to find is the limit of this sequence that we get over here. Whatever this new sequence is, we take the limit as n goes to infinity. If it goes to a number, that's what capital S is. Now, in general, it is difficult to determine S. Okay? In this class, figuring out what S is going to be hard to do. Because to figure out what S is, we have to be able to come up with the formula for that sequence. And finding a formula for this sequence is generally hard. All right? It's generally a hard thing to do. There are only 2 types of series in this class that we can actually find what capital S is. There's only 2. All right? They are geometric series and what are called telescopic series. Those are the only ones. All other series, we're only going to be able to say converges or diverges. That's it. It's going to be converge or diverge. So the only 2 series are going to be geometric and telescopic, which is the rest of this section. We're going to start now looking at what a geometric series is. All right?
Collapsing is telescopic.
It's the same as telescopic, yes.
How many kinds of series are there?
There's a series can be anything because you have series come from sequences, right? And sequences can be pretty much anything you can think of, right? Any formula you want to ever come up with could be a sequence, right? And then the series that corresponds to that is just adding them up. So it's like that's like asking how many different types of functions are there, right? There's an infinite type of functions, but we can categorize them, right? We say, oh, these functions are polynomials. These are rational functions. These are trigonometric functions, right? With series, we have the same sort of classification. We have, oh, all these series kind of look the same. We'll call these P series, right? P series, or we'll call them geometric series, or we'll call them collapsing or telescopic series, or we'll call them harmonic series, and there's all these different categories. Make sense? All right, do we need to clarify? I think I've made this straight. I hope so. Given a series, we look at the nth partial sum, we add up the first n, and then what we do is we let n go to infinity and see if we get an answer. If we can come up with that, if we can find a formula S sub n. If that happens, we say it's convergent. If it doesn't, then we say it's divergent. Now, our first test, the very first test, all right? I just told you that we're going to have to figure out what these series are doing, and there's going to be all these tests, right? The very first test is called the test for divergence. And I'm going to refer you now for the first time to a page in your notes, files that you can get your formulas, right? There was this thing called the convergence tests. Does that look familiar? That's it right there. This is the sheet that you're now going to be sleeping with. All right? Why is that not zooming in? Oh, there's zooming. See all these different tests? Okay. The very first test on this page, it's called the nth term test. The nth term test. And then the next part of the table tells you what type of series you're looking at that you can use this test on. So can you see from this that it appears we can use this on any series? Yeah? Can I use this? Is this all right if I'm here? Okay, so I can go to any series with this. Now in textbooks, a lot of times when you see this, it's implied that there's n equals 1 to infinity. It's implied. So if you don't see limits or indexes here, just assume it starts at 1, goes to infinity. Right, so this is saying you have any series, you can do this test. What's the test? Well, you take the limit of the sequence. You see how you've got a sub n in there? You're going to take the limit of the sequence. And it says that if that limit does not go to 0, goes to somewhere other than 0, what happens? The series diverges. All right? So look back at this one right here. If I'm trying to figure out what this series does, right? Like this one right here. If I'm trying to figure out what this does, then what I do first, if I want to run this test, the nth term test, is I will take this right here, I will take its limit as n goes to infinity. And what is that limit as n goes to infinity? What is it? Infinity, right? Therefore it diverges, right? Okay, I'm going to write this down formally. Let's do it this way. Let's do it more like a formal example. Does sum n equals 1 to infinity of n converge or diverge? All right, so watch how I do this, all right? I'm going to say nth term test. I'm now telling you what I'm about to do, right? I'm letting you know, the reader of my work, the test I'm about to run on this series to determine whether or not it converges or diverges. I'm going to use the n-term test. So what the n-term test says is that I need to take the limit as n goes to infinity of what? A sub n, right? A sub n, which for us is the actual formula right here, right? So I'm going to take that limit of that. And what is that? Infinity. And do you agree that that is not equal to 0? And that says that if I get something other than 0, the result is what? So this implies, by the test, that's the symbol for implication. That means it's like, if this is true, then this is true. So that forces this to be true. The series diverges. Done. I'm done.
On our test, is it okay if we do the 3 dots?
You can do the 3 dots at the end. Oh, you mean here? Okay, you can, instead of saying that, you can do that, or you can do, I think I do this mostly in my notes.
Yes.
I use this 3 dots, that means therefore. In math, 3 dots like that means therefore. So you're saying the limit goes to infinity, which isn't 0, therefore this diverges. Why? Oh, because I'm using the n-term test. The n-term test says that's the conclusion you draw. All right? See, does that seem like a logical statement to you? That's the way your work has to look. You have to, when you're doing your test, your final exam, which is where you're going to see this again. No, the next exam. When you see this, exam 3, I'm going to expect that I can read what you're doing, right? You can't just say, oh, you know, I ask you, does this converge or diverge? You're like, it diverges. Move on. You have to be able to justify your answer, which means you have to show me the test you're using, execute the test properly, logical steps, right? So this is a lot about you communicating with me what you're doing, right? Your thoughts. All right, good? All right, let's try this one. Same question, right? Does sum n equal 1 to infinity of 1 over n converge or diverge? I'm just going to start putting C or D because I hate writing those words over and over. Converge or diverge? All right, right now, we know that this diverges, right? We know it diverges only because I told you and because I tried to convince you visually, right? Other than that, we have nothing. So right now, you cannot tell me this diverges because we're acting like we never saw a picture, right? So does this converge or diverge? Well, the only test we've talked about, the only thing we've actually talked about is this first test, this n-term test. So I'm going to try it. I'm going to do the n-term test. And so what I'm going to do is I'm going to take the limit as n goes to infinity of 1 over n. And what does that go to?
0.
That goes to 0. Therefore, what? You don't know. Okay, this is critical. If it goes to something other than 0, you know it diverges. If it goes to 0, what does it say? Sorry, it's not on the screen there. What does it say? If it goes to 0, it's inconclusive. It's inconclusive. This is like, okay, this is like, I want to say, before COVID hit, I always used the pregnancy test as an example, but I guess we can do COVID tests now because everyone's familiar with COVID tests. You know when you do the COVID test or pregnancy test, however you want to look at this, right? It has like the 2 bars, right? And so like, if both bars show up, right? Like this one's called the control and this is the test. So if this bar shows up and this bar shows up, this is a positive test. Right? If that bar doesn't show up and that one does, then you're negative, right? Because this did not show up and that's a control. This control has to show up for the test to be valid. So what's happening here in this situation is we're getting 0. And that's like having this happen. Like what if you took a pregnancy test and you got that? What would that tell you? Go get another test, because the control's not here, which means this could be an invalid result. You don't really know what's happening. Make sense? Or if you take the test and you get this, invalid, right? That's kind of what's happening here. When the limit goes to 0, you need a new test. So we're going to have to do something else. Understand? The biggest mistake students make is they look at it like, oh, well, if it doesn't go to 0, it diverges. If it does go to 0, it converges, right? No. Someone's going to do it. Who's doing it? Someone's doing it in here. I don't think I've ever had a semester where a student didn't make that mistake. Who's going to volunteer? No? No one's going to make the mistake this test?
I'll see if I remember to do it on the exam.
Okay, yeah, wait, yeah, don't make the mistake on your homework, but wait till the exam to do it.
It's a harmonic series, isn't it?
Yeah, this is harmonic, but we haven't talked about that yet, yes.
So would this mean that the end test failed, or would you just use multiple tests to figure it out?
Well, it depends on how you want to say this. I don't really want to say the test failed. It failed to give us a conclusion, right? But the test did what it said it would do. It told us it doesn't know, right? So you could say, that this fails in the sense that we still don't know. So we have to move on to a different test. Is that what you're asking me? Like, yeah, we need to move on to something new. Another test off our list. Which I'm going to leave this as an open question right now because we haven't talked about the other tests yet, okay? I'm just trying to show you the contrast here between when the test does work and when the test fails to work or fails to give you a result. What about if I change this to the problem where we had n cubed? N cubed? Same answer. I wouldn't know what happens, right? Okay, so this is called, the n-term test is called the test for divergence, because all it will ever tell you is if something diverges. That's all it will ever tell you. I'll give you one more. Does this one converge or diverge? Converge or diverge? What's that? Okay, so what I'm asking you right now is, does the series converge or diverge? Right? You said 1. What are you looking at?
I took the used hospitality.
Okay, so you're giving me what the sequence goes to, right? Do you understand? This is asking what the series goes to. You gave me that this goes to 1, but you were saying that the sequence goes to 1. So what you actually just did was the n-term test. You did the n-term test, right? You did the limit n goes to infinity of n plus 1 over n plus 3, like that, right? And when we do that, you get infinity over infinity. You use L'Hopital's rule one time. You get 1 as an answer, right? You get 1. And 1 is not 0, right? 1 is not 0. And since 1 is not 0, what can you tell me? That series diverges. You see? The sequence converged to a number that wasn't 0, which means the series diverges. That's what the n-term test tells us. That will happen on an exam, all right? And I mean, people will tell me that this converges to 1, which is this, yes, but not the series, right? You see the difference? Okay, what about this? We'll do one more. What about this series, sine n? Converge or diverge? Well, let's try the nth term, right? Nth term. So nth term, I take the limit, n goes to infinity of the sequence, right? Of the sequence sine n. And what does that do? Do you remember the picture of that? It's like that, but it's all the dots, right? It's like dots everywhere. Is that converging? No. Well, it's not always going to be 1 or -1, right? Remember, it looked like this. It was like dots everywhere. Remember the picture of that? So is that converging or not? Is that going to a number?
No.
Is it going to 0?
No.
No. So would you agree this is not going to 0? Like whatever it's doing, it's not going to 0. Which means that this diverges.
Or we can do the absolute value.
You could, but it still doesn't go to 0, right? No matter what, it doesn't go to 0. And that's all you need. For the end-term test, you just need it to not go to 0. If it doesn't go to 0, you are done. Yes?
Even if it's bounded,
It is bounded. That sequence is bounded, yes. It's bounded between -1 and 1. But it doesn't go to 0, does it? It's like if you looked at the dots as you go out to the right, they don't go to 0. Questions? All right. Now, we're going to talk about our first important series, and that is a geometric series. So our first look at a geometric series, I can show it to you in a nice little picture. Let's say we have a square. Okay, you see that square? What's the area of that square? 1. Okay, so what I'm going to do, first thing I'm going to do, is I'm going to take that and shade half of it. So right there, that's 1/2 of that square. 1/2, right? And now what I'm going to do is add to that, I'm going to shade half of the half that's left. So I'm going to shade that half in red, right? So what's the area of that square right there? 1/4, right? So that's 1/2 a second times squared. That's 1/4. And then I'm going to shade this white region. I'm going to shade that half of that. So shade that. That's 1/8, right? So that's 1/2 to the 3rd power. That's 1/8. And I'm going to keep going, right? So half of what's remaining, that's 1/2 to the 4th power. And do y'all see the red number here? I have the computer go ahead, and the computer is adding these up for me, okay? The computer is adding these up. What is this going to go to if I keep doing this forever? I'm going to get closer to the true area, right? Of that. See how I'm filling in all those little pieces? If I could do this forever, does it make sense that this should head to 1? Right, the total area? So these added up forever should be 1. Like visually it makes sense, right? Visually it makes sense. This is your first example of what's called a geometric series. This right here. Now, can you find me the formula for that? Yep, find me the sequence. Yeah, okay, so what did you say?